All right, everybody. Well, welcome to another lesson with Ahmad. Well, sorry. Today, in our book, in our video, which is grade 10's book, the new book, we're going to talk about the new topic. It's not actually new because you already studied in like grades 7, 8, and especially 9. So you are familiar with these kind of topics that today I'm going to mention them in this video. But since it's in the book, so we have to cover them. All right. So let's go to that slide that it is for today's lesson. And here is the slide. Let's just play it. Okay. So the lesson is power and properties of power. So we are dealing with powers. You know, we already said that power is a repetition of multiplication of a number by itself. So repeating a multiplication of a number by itself. You might ask me, how, mister? So let's just go to here, power and exponent. So as a point, we can say, let's just bring the pen. Okay, so we can say power is repeating, okay, repeating of multiplication of a number by itself. All right, by itself. Okay, example, let's say if we have 6, number 6, if we multiply these 6 like sometimes by itself, let's say 5 times by itself, 6 times 6 times 6. That is a multiplication, a repetition of multiplication of number 6 5 times by itself. So we can show this multiplication statement as a power form, in a power form. So let's say we are going to say that, okay, it's equal to 6 to the power of, or powered by, or raised by, how many times it's multiplied by itself? 5 times. So we are going to say that 6 powered by 5, or 6 to the power of 5. Okay? So this means that this 5 will tell us that we multiply this 6 5 times by itself. By the way, in power form, that it consists of 2 parts, 2 components. So we can say that this one is called exponent, and the down part we call it base. Okay. So the exponent will tell us how many times we are going to multiply the base by itself. This is how the exponent acts and rules. So in our PowerPoint, we have got a representation of exponent and power. So exponent of a number, x to the power of n, x powered by n. We call that n exponent, and that x is the base. So x to the power of n means we multiply x n times by itself. So this n can be any number, okay? For example, if it is x to the power of, let's say, if our x is 2 and our exponent is 5, so it means we need to multiply that number to 5 times by itself, which means 2 times 2 times 2 times 2 times 2. This is how you evaluate the power when we have the exponent. Okay, so 2 to the power of 5 means 5 times multiply 2 by itself. Okay, that is all about power. So right now, the thing that it is important for you guys to understand in this lesson is, before diving deeply to that thing, is we are going to deal with these questions that it has solved these expressions. Let's just solve them. I mean, here we have got 3 to the power of 7. So that 7 will tell us how many times we are going to multiply 3 by itself. Perfect. 7 times. So we are going to say that, okay, 3 times 3 times 3 times 3. How many times? Here are 4, 5, 6, and 7. I'm not going to ask you to find the result because the result of this one is a huge number and you don't need to find it for me. So how about negative 2 powered by 4? So we have to multiply negative 2 how many times by itself? Perfect, 4 times. So we are going to say that negative 2 times negative 2 times negative 2 times negative 2. So 4 times negative 2 multiplied by itself. And finally, we have got a fraction, which is 1 over 3 powered by 5. So the fraction is 1 over 3, which is the hour base of the power form. So 1 over 3 times 1 over 3 times 1 over 3 times 1 over 3. How many times we have it? So it's 4 times, and we need one more, which is multiplied by 1 over 3. So 5 times 1 over 3 multiplied by itself. That means exactly this power form, which is 1 over 3 powered by 5. And I hope till now the video and the lesson is completely clear to you guys. We have power that it consists of 2 parts, exponent and the base. Well, exponent will tell us how many times we will multiply the base by itself. Let's go to the major part, which is the properties of powers. We have some important and crucial properties that we need to know regarding the powers. Okay, that you already studied them, by the way. So the first one, the first property is product of powers. When we have power with the same base, remember, bases must be the same. Then we will follow this property. Product of powers says that if we multiply powers with the same base, we will keep the base and add the exponent. So in product, keep the base and add the exponent. Okay, this is exactly what this mathematical statement means. So b to the power of m times b to the power of n equals to b to the power of m plus n. That just may turn into a numerical example. Let's say 2 to the power of 6 times 2 to the power of 9. So here, as you can see, the bases are the same, which is 2. So keep the base, don't change the base, and add the exponent. 6 plus 9 is equal to 15. So 2 to the power of 15. One more example, let's say 2 to the power of 4 times 2 to the power of negative 7. So keep the base and add the exponent. So 4 plus negative 7 is equal to negative 3. And later on we will study that we are not okay with negative exponent. Whenever we have it, we are going to flip it. Take the reciprocal form. So here is the denominator of 1 over 2 to the power of positive 3. This is how you are going to turn a negative exponent to a positive exponent. All right. That is regarding to the product of powers. How about the divide of power? So in divide, we will keep the base again. Never change the base, gentlemen and ladies. So never change the base, keep it. But in divide, we are going to subtract them. There is a typical mistake here, so it's equal to b to the power of m divided by b to the power of n. It's equal to b to the power of m minus n. We will subtract the exponent. Let's just take some questions. So here, let's just make as minus. Let's say 2 to the power of 7 divided by 2 to the power of, let's say, 2. So we are going to have this rule, which is keep the base and subtract the exponent. So 7 minus 2, it's equal to 5. 7 minus 2 equals to 5. Perfect. How about 2 to the power of 6 divided by 2 to the power of negative, let's say, 1. So keep the base 2 and subtract the exponent. So let's just subtract the 6 minus negative 1. That negative times this negative, it's positive. It's going to become positive. Remember the essential information of mathematics. So negative times negative, positive. So in that case, it's going to become 2 to the power of 6 plus 1, which is 2 to the power of 7. Okay? I hope that the examples are clear. So as a fraction, you can show the quotient rule. For example, 2 to the power of 13 over 2 to the power of, let's say, 5. That quotient bar means divide. Okay, that line. So to keep the base, don't change it. 13 minus 5. 13 minus 5 is equal to 13 minus 5. So it's equal to 2 to the power of 8. That is how we are going to act in divide of powers. Keep the base and subtract the exponent. The next case is power of power. Yes, power of powers, when we have two exponents together and one bracket between them. So in that case, again, the same, the common sentence, which is keep the base, never change the base, and multiply the exponent. Example, you are going to ask me, teacher, give us numerical example. All right, let's say x to the power of 3, all powered by 7. So in that case, if I ask you to evaluate it, you are going to say that, okay, keep the base, x, and when we have two exponents and one bracket between them, so we are going to multiply these two exponents. So 3 times 7, it equals to 21. Perfect. Let's just say that if we have 2 to the power of negative 3, all powered by negative 4. So in that case, you are going to say that, okay, keep the base, which is 2. Negative times negative, positive. 3 times 4, it equals to 12. This is how you are going to evaluate that type of power, guys. And the next one, the next property that we have is power of product. When we have a bracket, and in our bracket we have a product, let's say, so that power outside of the bracket will be distributed on each term inside the bracket. Let's say if we have 2x, all powered by 6. So that 6 will be distributed on each term inside the bracket. We are going to raise and power each term in the bracket by that exponent that we have it here, which is here. So 2 to the power of 6 times x to the power of 6. Okay, 2 to the power of 6 times x to the power of 6. If you knew the numerical part, you can just turn it to single, number. 2 to the power of 6 is equal to 64 x to the power of 6. So both terms are okay. So it depends on your teacher which one she or he's gonna consider as a correct answer. That is about power of product. So when we have a product in a bracket and a power outside, that power will power each term inside the bracket individually. All right. How about the next property? The next property that we have is power of quotient. When we have a fraction, basically a quotient in a bracket, and again it's powered by a number, so that number will work on numerator and denominator both. All right. How? Let's say if we have 1 over 3 powered by 4. So that 4 will power the numerator and denominator. All right? Which means 1 to the power of 4 over 3 to the power of 4. So that 4 basically is for both of them. 1 to the power of 4, it's 1, because 1 powered by any number, it's 1. And 3 to the power of 4, you may just leave it like 3 to the power of 4. It depends on the title of the question. Or you can just find it out that it is equal to 81. Okay? You might ask me, what if the exponent was negative? Perfect question. I love this kind of question. Well, let's say, what if we have 2 over 3 powered by negative 2? The exponent is negative. As we already mentioned, when we have negative exponent, we have to flip the fraction, the quotient that we have. We have to take the reciprocal form. Example, 2 over 3 to the power of negative 2. We have to flip it, which means change the place of numerator to denominator and vice versa. So these 2 will come down and these 3 will go up. So it's going to become 3 over 2 powered by, automatically the negative will become positive. So it's going to become positive 2. So 3 to the power of 2, 9. 2 to the power of 2, 4. This is going to be the result. Okay, that was about the properties that we have here. Sorry. Let's just move to the next slide. We have got some important notes that we need to take care of them. Okay, when we have a term like this, negative b, I'm sorry, let's just, sorry, negative b to the power of n, when we have such a term, so we have to know what kind of number do we have instead of n. Is it even or odd? Because based on that, the result will be changed in terms of sign. Okay, negative b to the power of n. If n is even, which is negative b powered by an even number, the result will be positive. Example, negative 3 to the power of 6. Well, the result is exactly positive 729. Why? Because n is even. So again, I'm going to repeat it. When we have such a term, I mean something negative in a bracket powered by a number, if that number was even, the result of that power form would be positive. For example, here, negative 3 to the power of 6. So the result is positive 729, which means if you multiply negative 3 6 times by itself, you're going to get positive 729. In another side of the story, we have got this. If n is odd, which is negative b powered by n, an odd number, the result is going to be negative. For example, if we have negative 3 powered by 3, the result is negative 27. Let's just analyze it. So negative 3 times multiplied by itself, negative times negative, positive, positive times negative, negative. Therefore, we can say that, we can conclude this idea that if n was even, the result is positive. If n was odd, the result is negative. Let me just check the camera. Yes, no problem. Okay, we have some crucial notes here. The first one says that any number raised to the power of 0 equals to 1, except for only these cases, this case which is 0 powered by 0, that is going to be undefined. For instance, let me just give you some example here. Let's say 3 powered by 0, so it's equal to 1. Any number raised to the power of 0 equals to 1, except for 0 to the power of 0, which is gonna be undefined. All right. So any number, no matter it is negative or positive, let's say negative 3 to the power of 0, so it's gonna be 1. So any number except for 0 powered by 0, which is gonna be undefined. Okay. And I hope that this note is also clear. So let's just move to the next one in case, let's see, yes, we have got one more. 1 powered by any number is itself, which is 1. So 1 powered by any number, it's equal to still 1. Any number powered by 0 equals to 1, except for 0 itself. Any 1 powered by any number is equal to 1. The next thing that we have got these examples. I'm gonna do like one of them, then I will leave the other two. You can mention the answer of them in the comment for me. I'm gonna check it for you guys. So please just follow me for one of them, then I will move to the next slide and I will leave these two for you guys. As I can see, this one looks like a little bit, okay, all of them are okay to be solved. So I might solve these two, because one of them is multiplication, the other one is division. So here, we have got a quotient powered by a number. First of all, so we have 2, okay, x to the power of 8 divided by x to the power of 2. So x to the power of 8 divided by x to the power of 2. Keep that x in division. We will subtract the exponent. 8 minus 2, 6. So 8x to the power of 6 will be remain will be left in the numerator. How about y to the power of 3 over y to the power of 5? These 3 will cancel 3 of these 5, and only y to the power of 3 will remain. I'm sorry, y to the power of 2. 3 will cancel 3 of these 5, so only 2 will remain in the denominator. Or you can say y to the power of 3 divided by y to the power of 5 if you just bring it up. So it's going to be y to the power of negative 2, because 3 minus 5, negative 2. So if you just flip it and bring it down, it's going to become y to the power of 2. So you can just do the cancellation. It's going to be easier. So powered by 5. Right now, 2 power, that 5 will work on each term inside this bracket. So 2 to the power of 5 times x to the power of 6 all powered by 5 over y to the power of 2 all powered by 5. So let's just simplify. 2 to the power of 5 is 32 times x to the power of 6 powered by 5. It's power of powers. So in that case, keep the base and multiply the exponent. 6 times 5, 30 over y to the power of 2 times 5, 10. That is how you are going to evaluate and simplify a power problem. So I will leave these two for you guys. One multiplication, product, and one more quotient. So you may just solve them by yourself and check it whether you understood it or not. The next thing that we are going to talk about is the next lesson is like a radical. So it's important to know the parts of radical that we have it and we face it. So the first thing is, that is the radical notation, symbol of radical, sorry. Whatever we have under our radical, we call it radicand. And of course, that number in that corner is called degree of our radical, or sometimes it's called index. And that line that covers the radicand, it's called like Wincombe. So these names are not necessary, but if you know them, it's going to be okay and cool. Okay. I'm not going to ask you what is the name of that part, or you will never see such a kind of question. Okay, so we have square root. Basically, square root is very important to be known in these states that we are in, which is 10th grade. So this is the symbol of square root. Okay, that sign. And here we have got something regarding to square roots that we need to take care of them and know them. The number m is a square root of n. When we express m to the power of 2 equals to n, like square root of n equals to m. So this is exactly, it's going to tell us that square and square root are opposite of each other, inverse operation, or opposite of each other. Let's say, if we have square root of 16 equals to 4, look, the number m, 4, that m is 4 here, is a square root of n is 16. When we express m squared, which is 4 squared, equals to 16, and also it can be written as square root of 16 equals to 4. So that is a relation between square root and square. Okay? And the next thing that we need to know is, for every positive real number, I'm going to repeat it. For every positive real number, there are 2 square roots. One positive and the other one is negative. Example. Let's say if you have square root of 25, so we are going to have 2 roots, one positive, one negative. So the square root of 25 is equal to positive and negative 5. How? 5 times 5 is equal to 25. Right? You agree with this, right? How about negative 5 times negative 5? Still it's equal to 25. How? Negative times negative, positive, 5 times 5, 25. Therefore, square root of 25 or square root of a positive real number always has two square roots, one positive and one negative. Let's see what we have here. Yes. Square root of a positive real number can be written as an absolute value of x. We already mentioned that in grade 9. Absolute value has absolute value of a real number has like two answers, one positive and one negative. For x is greater than 0, it's equal to the positive. For x is greater than less than 0, it's going to be with negative. So basically, let's not make it complicated. Square root of positive real number has two square roots, one positive and one negative. For instance, one more example. Let's say square root of 17. So it's equal to positive and negative square root of 17. Okay? So we don't know exactly how much is square root of 17. So it might be equal to like 4 point something. All right. So square root of, let's say 100. Since it's perfect, it's easier to understand. So square root of 100 is equal to 10, but with positive and negative. Okay, because 10 times 10 is equal to 100. Negative 10 times negative 10, it's equal to 100 as well. So the next thing that we need to know about square root, here we have got something very important. As we already mentioned, square and square root are inverse of each other. So if we have square root of b, the index n equals to a, so it means that a to the power of n equals to b. Perfect. That relation is between square root and the exponential function, basically. So here, square root of 81, let's just analyze it here. Square root of 81 is equal to 9. All right? It means that 9 to the power of 2, where did we bring these to? The index of our square root is 2. Therefore, 9 to the power of 2 is equal to 81. Okay? And cube root of 64 is equal to 4. So it means 4 powered by 3 equals to 64. Okay? Fifth root of 32 is 2. If we turn it to exponential function, so it's going to be 2 powered by the index, by the degree, which is 5. 2 powered by 5 is equal to 32. So if we have fourth root of 16, so that means what number powered by 4 equals to 16? This is exactly what does this statement means. So fourth root of 16 is equal to 2. Means that 2 powered by 4 equals to 16. 2 powered by 4 equals to 16. Perfect. And finally, cube root of 1000 equals to 10. So it means that if we multiply 10 3 times by itself, it's going to give us 1000. That's why cube root of 1000 is equal to 10. That's it. Square and square root are inverse of each other. Let me just check the time. No problem, we can just continue. Okay, properties of square roots. So we have got some properties regarding these square roots. First property, it says that square root of a number times the same square root, the square root of the same number, is going to give us just the number without the square root. Example. Let's say if we have square, I hope that the color is clear, square root of 2 times square root of 2, so it's going to give us only 2 without the square root. So as a reason, we can say that why this is going to be happen. 2 times 2, 4. So square root of 4 is equal to 2. But simply, according to this property, we can say that square root of any number times the square root of the same number, the result is going to be just the number without the square root. Okay. How about the square root of a product? For example, the square root of A times B. we can separate these two numbers in different square roots. For example, square root of 2 times square root of, let's say, x. So it's equal to square root of 2 times square root of x. Okay? So since we have got a product here, we can separate them into different square roots and then multiply them. So a numerical example can be like 2 times, let's say, 9. So it can be written as 2 square root of 2 times square root of 9. So square root of 9 is perfect. It's going to become 3. So basically we can write as 3 square root of 2. Square root of 3 is not perfect, so it's going to stay the same. How about if you have a quotient under the square root? Let's say, so we can again separate them. Square root of the numerator over square root of the denominator. Example, square root of 36 over, let's say, 4. So basically, it's going to give us square root of 36 over square root of 4. So square root of 36, it's 6. Square root of 4, it is 2. 6 over 2, it's equal to 3. According to this property. Be careful, b should not be 0, because if it is 0, it's going to be undefined. Alright. And then we have something else. So you have this idea as well that you can divide here and get rid of this part. 36 divided by 4, 9. So directly square root of 9, it's 3. Perfect. That was about the properties of square roots. So simplify these radicals to their simplest form. Let's just do it quickly. Square root of 144, it's equal to 12. You know that 12 times 12 is equal to 144. Square root of a negative number, we already mentioned this case in first lesson regarding the set of numbers. If we have negative under the square root, it's going to be a non-real number. It doesn't belong to real number sets. How about 4 over 81? So we can use the property that we had already, 4 over square root of 81. So it's going to give us square root of 4, it's 2. Square root of 81, it's 9. Okay, 2 over 9 is the result. And I will leave this one for you guys. I hope that you can solve them. Next thing that we have doesn't work, yes? Okay, the next lesson of this PowerPoint, which is the relationship between radical and rational exponent. As I already mentioned that if we have roots of x to the power of m with the index n or degree n, so it's the same if we turn it to the exponential function or a rational exponent, a number raised by a rational exponent. So the base will not be changed. X stay with the same, will stay the same, like as the base. And then always you are going to divide the exponent of inside over the index. So you are going to divide the exponent inside by the index, or the degree, you can say. Just like here, x to the power of m over n. A numerical example can be something like this. So let's say a to the power of 3, a to the power of 8, and here 3. So you can write this one as a to the power of 8 over 3. Okay? You can write this root as a rational exponent of this number, which is a, of this base. One more example, let's say root of x to the power of 5, cube root of x to the power of 5, or yeah, so it's equal to, keep the base, don't change it. We said that we will divide the exponent inside by the index that we have, 5 over 3. Okay, this is the relation between nth root of exponential function and turn it to a rational exponent of a number. We have these two examples. Find the square root of each of these questions that we have. So basically it means that we need to turn them to rational exponents. Okay? For example here, 27 powered by 4 over 3. But guys, here there is something tricky that you need to take care of it. 27 itself can be written as 3 to the power of 3. Okay? 3 to the power of 3. Then out of this, our rational exponent is 4 over 3. We already studied that power of powers case. So we are going to multiply these two exponents. Okay? So it's going to be 3 to the power of 3 times 4 over 3. These two 3 will cancel each other, and only 3 to the power of 4 will remain. That's it. So you have to understand, realize whether this number in the base can be written as a power form or not. For example, here, again 32. So it's equal to 32, the exponent divided by the degree. So the question is, can we write 32 in a power form? Yes, we can. How? You know that, guys, 2 to the power of 5 is the same with 32. 2 to the power of 5 is the same with 32. So I'm going to turn it to power form because it's going to help me to cancel this power. Okay, this is rational exponent. So all powered by 3 over 5. Again, we have 2, keep the base. Multiply these two exponents, 3 over 5. These 5 will cancel this 5, and only 2 to the power of 3 will remain. So 2 to the power of 3 is 8. That's it. So in these kind of cases, guys, you have to realize and find it out whether the base under the square root can be written as a power form or not. If it could be, you have to turn it to the power form in order to cancel the rational exponent if it was possible. And finally, when we simplifying the addition and subtraction of radical expression, we try to find common terms between them. So when we are going to simplify addition and subtraction of radicals, our point is we have to find common terms in case if it exists. Okay. After identifying the common radicals, we add or subtract their coefficient as follows. So here is the general rule. A square root of x plus minus, doesn't matter. B square root of x, since their common part is root of x, so we are going to write this one as a common factor and add or subtract only their coefficient, guys. Do not add or subtract the roots part. Only add or subtract their coefficient. Let's just take some examples. Yes, simplify this expression. Let's do one of them or two of them, then I will leave the others for you guys. Negative 11 square root of 5 minus 3 over square root of 7 plus 1 square root of 5 plus 6 square root of 7. So do we have common square roots? Yes, we do. Here we have got square root of 5, and here we have got square root of 5. Here we have got 3 square root of 7. Here we have got 6 square root of 7. So these two together can be subtract or add, and these two can be subtract and add to each other. So let's just do it. Okay, these two, negative 11 plus 1 times the common square root, the common part, which is square root of 5. Okay, and then plus bracket negative 3 plus 6 square root of 7. Remember, you have to add or subtract the like terms, the like square roots. So here negative 11 plus 1, it's equal to negative 10 square root of 5 plus negative 3 plus 6, it's equal to how much? Perfect, 3 square root of 7. That is how you are going to simplify a statement that it includes different square roots. And this is the final solution, by the way. You cannot simplify more than this. All right? So I will leave the second one and I will solve the last one as well in order to make it clear, inshallah. So here, do we have common square roots? Yes, we have square root of 7, square root of 7 again, square root of 11 with square root of 11. So these two together and these two together. Okay? So negative 6 inside the bracket plus 5 all times their common square root, which is square root of 7 plus bracket negative 3 plus 8 multiplied by their common square root, which is square root of 11. So negative 6 plus 5, it's going to be negative 1 square root of 7. Negative 3 plus 8, positive 5 square root of 11. That is how we are going to simplify statements that it includes, expressions that it includes like different square roots. For example, square root of 11, square root of 7. So basically, we are going to just subtract or add their coefficient and keep the common square root as it is. So how about this kind of expression, algebraic expression? Square root of a to the power of 8, a to the power of 8 times b over c to the power of 4. There is a note here. Let's just see what we have here. Yes. When we take square root of an even power, we divide the exponent by 2. If the result is even, why we divide it by 2? Because the index of square root is 2. The starting index is 2. Don't forget this one. This is the reason that we divide it by 2. If the result is even, we don't need to put it in an absolute value. But if the result was odd, we must put it inside an absolute value. What do you mean, teacher, by this? Let's just find it out through this example. So, here we have got a to the power of 8. So if you want to just take it out, it's going to become a to the power of 8 divided by 2. 8 divided by 2, it's 4. Is it even or odd? Even. So if the result is even, we don't need to put it in an absolute value. So we don't need to put this one in an absolute value. Okay, how about this one? B cannot come out because their coefficient is not divisible. Their power, their exponent, its exponent is not divisible by 2. And B's power is 1, so it can't come out. Therefore, it's going to stay under the square. Under the root, b to the power of 1. And then we have got c to the power of 4. So just like that's a, we are going to divide that 4 by the index. So 4 divided by 2, it's equal to 2. And since it's even, we are not going to put it inside a absolute value. So it's going to come out as c to the power of 2. Okay. So right now we have got this note. Again, let's just take a look at it. When we take square root of an even power, okay, even power, just like here, 8 and 4, they are even power, and we took like square root of them. We divide the exponent by 2. Why 2? Because the index of square root, it's 2. I wrote it over here, but basically the writers, the authors, they don't write because the starting index is number 2. So if the result is even, just like here, 8 divided by 2, 4, and 4 divided by 2, it was 2. So in both cases, the results were even. We don't need to put it in an absolute value, but if the result was odd, we must put it inside an absolute value. Since here the result for both case, like A and C, were like even number, even, so we don't need to put them in an absolute value. But we have got a case here. Let's see. Yeah, we have an example, a beautiful example here. Square root of x to the power of 4, y to the power of 6. So in both cases, it's divisible. I mean, the exponent is divisible by the index. So if we want to take out this expression from this square root, let's see how we are going to do it. So x powered by 4. 4 divided by 2, it's 2. The power is even, so x equals x to the power of 2 will remain. Since it's even, we don't need to put it in an absolute value. But how about y? Y powered by 6. 6 divided by 2, well, it's going to be y to the power of 3. Here is the point. It says, if the result was odd, we must put. What I mean by odd, if this exponent that you got it after the division, after dividing like exponent by the index, if it was odd, you have to put that part in an absolute value. Okay, so we must put it inside an absolute value. That is regarding to that note, and I hope that this note is clear by solving these two questions. Okay, so let's see whether we something left or not. Let's just move to the next page. It seems we have got some questions again. Simplify these expressions. Oh my God. Okay, some important questions. We have got some important questions. Let's see what kind of questions are they, because I do remember that when I just prepared this slide, I checked the book and there were some type of questions in the exercises that during the lesson, it didn't mention these type of questions. That's why I decided to bring such a questions to my PowerPoint and solve them and deal with them in order to represent it here and aware you from them. All right. So the first question is two parentheses that they multiplied by each other, and as you can see, one of them is square root of 2 minus 3, square root of 2 plus 3. How are you going to multiply them? Again, you already studied these kind of questions, but let me just remind you this idea, that strategy through this problem. Okay. Remember, there was a property that it says like difference of perfect squares, two perfect squares. Okay. For instance, we had such a things like a square minus b square was equal to, we said that we are going to open two brackets. We will share this a, one a for here, one a for here. So these two brackets, one of them is going to be with minus, the other one is going to be with plus. Okay. So then we will do the same thing. We will distribute this b into like these two brackets, one b for here, one b for here. Okay. So as you can see right now, we have got the right side and we need to get the left side in our questions. Let's take a look at it. Yes. So imagine square root of 2 is our a and 3 is our b. So here is a and here is b. We have two parentheses and one of them is with minus, the other one is with brackets. So we have the right side and we are responsible to get the left side. How are we going to do it? So we are going to say that, okay, since square root of 2 is a, so a square, square root of 2 square minus, between them there is minus. B square, what is our b? 3. So 3 square. Okay, so recently we mentioned that square and square roots are inverse of each other. So if they come together, they are going to eliminate each other. Therefore, this square will kill this square root and only 2 will remain. So 2 minus 3 square, 9. Okay, so 2 minus 9, you know guys that it is equal to negative 7. That was beautiful questions, and I guess there are similar questions regarding to this one in your exercises in section 2, lesson, in chapter 1, of course, lesson 2. Go and check it. I'm pretty sure there are questions similar to this one. So let's see whether we have got any other question or not. Yes, we have got one more question. Right now, what if A and B were not the same? So we have to simplify them, then multiply the bracket by each other. Okay, so for instance, square root of 48 minus square root of 9, that is perfect, it's equal to 3. Square root of 27 minus square root of 75. Well guys, here you have to simplify. There is no other way. And you cannot say that, okay, sorry, square root of 48, for example, it's equal to 6 point something. We are not sure what is that something. Minus, okay, square root of 9 is perfect, it's 3. Square root of 27, it's like 3 square root of 3, so that's not, 5 point something. And square root of 75, it's 8 point something. So since we don't know the exact amount, we have to use simplification, okay? We have to simplify. So square root of 48 can be written as square root of 16 times 3, okay? Therefore, 16 is perfect. So it's gonna come out as 4 square root of 3. Okay, so right now let's just rearrange it. 4 square root of 3 minus square root of 9, clearly it's 3. Multiply by square root of 27. Well, square root of 27, guys, it's equal to 9 times 3. Okay, so 9 times 3, it's equal to how much? 9 is perfect. So it's going to come out as what? As 3. So the result is going to be 3 square root of 3. Okay, so instead of square root of 27, I'm going to write 3 square root of 3 minus. How about square root of 75? Let's just simplify this one. See whether we can or not. Square root of 75, if you go and check it, it can be written as 25 times 3. Perfect. So 25 times 3. So 25 is perfect. We are going to bring this out as 5. So 5 square root of 3. Perfect. Very nice. So right now we are going to have 5 square root of 3. We can subtract these two because we have got like square root. So 3, for such a cases, remember we said that we will subtract the coefficients and keep the like square root. So let's just rearrange it again. 4 square root of 3 minus 3. We cannot subtract these two. Sorry, it should be 4 square root of 3 because they are not like term. And this one here, 3 minus 5, it's equal to negative 2. Keep the square root, which is square root of 3. Now, distributive property says that here we need to distribute that term into each one of these two terms in this bracket. So negative 2 square root of 3 times 4 square root of 3, negative 2 square root of 3 times negative 3. So let's just do it. First of all, negative 2 square root of 3 times 4 square root of 3. 4 square root of 3. Okay. Negative 2 times 4, negative 8. In multiplication, we are allowed to multiply the square roots. Square root of 3 times square root of 3. Again, the property of square roots, they are the same, so only 3 will remain, times 3. So negative 8 times 3, it's negative 24. So we got negative 24 from the first one. Minus negative 2, again, square root of 3 times just negative 3. Well, let's say 3, because that negative, later on we will, it's about the subtraction, okay, 3. So negative 2 times 3, negative 6. Well, it's equal to negative 6 square root of 3, because there is no square root of 3 to multiply it by. That's why I just multiply that number by the coefficient, then rewrite the square root with it. So negative 6 square root of 3. So right now the final result is negative 24 minus, why minus? Because there is minus here. Minus negative 6 square root of 3. So negative times negative, I can write it as positive. So finally we can say that, okay, let's just use white. So negative 24 plus 6 square root of 3. That is the final result of this question. And it was very, very nice question. I'm going to just shortly explain it what we did. So here we said that square root of 48 minus square root of 9 all times square root of 27 minus square root of 75. So since they are not the same, we cannot use the property that we already used, the identity, I mean, the specific identity that we used for that one. So we cannot use it for here because the terms are not the same. Okay, so we have to simplify. All right, square root of 48 is equal to 16 times 3. 16 is perfect. It's going to come out as 4. So 4 square root of 3. So rewrite it. 4 square root of 3 minus square root of 9 is perfect. It's 3. So in the other bracket, we have square root of 27. So if we simplify, it's equal to 9 times 3. So 9 is perfect. And since 9 is perfect, it's going to come out as 3. So 3 square root of 3. Okay. And square root of 75, it's the same with 25 times 3. So again, 25 is perfect. 25, since it's perfect, it's going to come out as 5. 5 square root of 3. Okay. So rewrite this bracket again. Instead of 27, square root of 27, I wrote 3 square root of 3. And instead of square root of 75, I got negative 5 square root of 3. Perfect. So then, I said, since these two are like a term, they have got a like square root, we can operate them. There is a subtraction between them, so let's just subtract them. 3 minus 5, just subtract the coefficient. Be careful, guys. So 3 minus 5, negative 2. Keep the square root, negative 2 square root of 3. So we have got a term here and a bracket here. So we need to multiply that term into each term inside this bracket. Perfect. Distributive property that we studied in lesson 1. Okay, negative 2 square root of 3 times 4 square root of 3. The coefficients are, like, if you multiply them, negative 2 times 4, negative 8, square root of 3 times square root of 3. Again, the property, only 3 will remain. Square roots are going to cancel each other. So negative 8 times 3, negative 24. And negative 2 square root of 3 times these 3. So negative times, negative 2 square root of 3 only times 3 because we need this subtraction, this minus. So 3 times negative 2, negative 6 square root of 3. Remember, there is no square root of here to be multiplied by this square root and cancel it. That's why just multiply that number by the coefficient. Do not multiply that number by the number inside the square root, okay? So here, finally, we are going to, let's just summarize it. So negative 24 minus, why minus? Because we have got minus in this bracket between these two terms. Minus, and we got negative 6 square root of 3 in the second multiplication. So these two negative, we know that negative times negative, positive. So finally, negative 24 plus 6 square root of 3. That is the final solution for this question. And again, there are some questions exactly the same with this question in your exercises. Okay, do we have any other question? Yes, we have got it. Something like similar to the previous notes, previous slide that we discussed about it. Let's just do it. Square root of 9, a to the power of 6, y to the power of 7. There is something here, guys, I want you to focus on it and see how are we going to deal with this kind of question. Well, 9 is perfect, so it's going to come out as 3. A to the power of 6, so is 6 divisible by 2? We will divide it by 2. Why? Because we said that index for square root is 2. So 6 divided by 2, it's 3. Since it's odd, we are going to put it inside the absolute value. So it's equal to a to the power of 3. How about this y to the power of 7, guys? Let's just separate it here, y to the power of 7. So we cannot say that, okay, 7 is not divisible by 2, so we cannot bring out this y. Actually, we can. But how are we going to do it? We need to simplify that y to the power of 7. Can't we write y to the power of 7 like in this way? Y to the power of 6 times y to the power of 1. We can, right? Because look, according to the property of powers, if we have product of powers with the same base, we will keep the base and add the exponent. So 6 plus 1, 7. So we can write y powered by 7 in that way too. Alright, now we can bring out y to the power of 6. Why? Because 6 is divisible by 2. So 6 divided by 2, y 3. So we can say that y 3 and only one y would remain under the square root. Y to the power of 1. We cannot simplify it more, and 1 is not divisible by 2. Therefore, that y will stay under the root. Okay, so the result is 9 was perfect, came out as 3. A to the power of 6, so 6 is divisible by 2. It's 3. Since it's odd, we put it inside an absolute value. And we break down this y into two pieces. So y to the power of 7 became y to the power of 6 times y to the power of 1. 6 is divisible by 2, so it's going to come out as 3. Y powered by 3. You can write these two in one absolute value together. So let's just do it. 3 absolute value a to the power of 3, y to the power of 3 all together, and square root of y. So both ways are correct. And I hope that you got benefit from these 3 questions, because they are really important and challenging actually. So during the exercises you will definitely face them, and generally this is the end of this lesson. And I hope guys that you go and solve the exercises. In case if you face any problem, you may just share it with me in the comment, then we will talk about it. I will share the solution of that question that you're stuck in it. So take care of yourself and see you in another video. Thank you so much for listening to me.